Check out these stunning pictures JWST just took of spiral galaxies. It's not hard to understand why scientists are so intrigued by spiral galaxies. They're stunning. And also, our own Milky Way is one. Studying how these galaxies formed and achieved their shape helps scientists understand how we got here. JWST's latest image series is part of the project Physics at High Angular Resolution in Nearby Galaxies, or PHANGS. Yes, they name things like this on purpose. The aim here is to study the way the small-scale things, like star formation and the physics of gas, interact with the large-scale things, like galaxy formation and structure. Images like this help scientists understand how galaxies grow. The prevailing theory is that spiral galaxies grow from the inside out. That is, star birth begins at the center and then moves out through the spiral arms. Scientists study this by taking high-resolution observations of galaxies with different telescopes. They've used Hubble, ALMA, and the VLT in visible, UV, and radio wavelengths. And now it's JWST's turn. The remarkable thing about these images, apart from how stunning they are, is how much detail they show in these 19 galaxies. These photos add the wavelengths of near and mid-infrared to the mix. NIRCam, or JWST's near-infrared camera, is what captured the glowing stars. You can see millions of them in these images. Being able to resolve individual stars this far away is a big deal, and it's so cool that JWST can do this. MIRI, or JWST's mid-infrared instrument, showcases dust. In these images, the dust is around and in between the stars. Remember, infrared light is good at peering through gas and dust. And when it does that, the stars appear red. These red stars are the stars that haven't yet emerged from their gas and dust shell. They're the newest and also the most massive you can see here. And where you can see holes in the gas and dust may be from where stars have exploded and cleared away this material. You can also see how some of JWST's images of these galaxies compare to Hubble's as part of this project. You can really see how stark the difference is between the two observatories in this image of NGC 1512. Hubble's here is in UV and visible light. JWST shows glowing dust, while Hubble depicts the dark regions where dust is absorbing light and the telescope can't penetrate it. Here's another one. You can see just how much scientists were missing by not having the infrared view of this galaxy. Going back to the JWST images, what's really interesting here is on some of these galaxy centers, you can actually see diffraction spikes. These usually only appear on individual stars, not galaxies. For more on why these distinctive spikes occur, watch my video on diffraction spikes. This is a good sign that these galaxies have either active, supermassive black holes at the center of their galaxies, or star clusters located around there that are bright enough to saturate that area and cause diffraction spikes.